morning, geometry class. Welcome to your Friday lesson on isosceles proofs. I wanted to first show you the answer key that went along with your homework assignment yesterday. So please grab your parallel proofs practice worksheet. At any time you need to stop this video to make sure you're checking your answers over, please do so. The answers for page 1 are up on the screen. The answers for page 2 of your proofs. Notice that with both of these particular examples, okay, there may be other options on how to do some of these proofs. These are two different ways that you could have done number 6 and number 7. Okay, number 6, you may have had vertical angles in that picture as well. You could have solved that with vertical angles in addition to the alternate interior angles that are up on the screen. Last but not least, your final page. Okay. Number 8 is one of the longer proofs that you will have, and notice that it is CPCTC that you are trying to prove for your very, very last reason. And number 9, there are both ways that you could see number 9. Feel free to stop this at any point. Now, if you could please take out or hand out the notes on isosceles triangle proofs. You'll notice first that we have to talk about a little vocabulary before we get started here, because the definition of isosceles is going to be one thing that hopefully you remember from earlier in this unit. The definition of isosceles is when you have two sides of equal length. So in this particular picture, we know that our AB is congruent to our side AC. Okay? We know other things from this as well. It's kind of thinking the opposite now. If you know that two sides are congruent, so if you notice the triangle in the second part, we already are given that AB and AC are equal. They're the exact same distance. We know then that the two opposite angles have to be congruent as well by the isosceles triangle theorem. So we know that those two angles are the same. So in this case, angle B is congruent to angle C. Okay. Now the converse. Think about what converse means. If you remember back when we were writing our sentences with conditional statements and converses, we switched to hypothesis and conclusion. So now we're given the opposite information. We have two angles now that are congruent. So if anytime you know that two angles in the same triangle are congruent, then the two opposite sides have to be congruent as well. So we are given those two pieces of information, which means in this case, we could conclude that AB is congruent to our BC. And again, it's the side directly opposite both of those angles. Now, let's work with a little bit of practice with each one of those. So what we're trying to do here is we're given a piece of information for both 1 and 2, and we're trying to figure out what we know from this. So you can hopefully recognize that in number 1, you have two sides that are the exact same. If you know two sides by the isosceles triangle theorem, isosceles triangle theorem, you know that the two opposite angles are the same. So that would be angle U and angle S. So make sure you use correct notation, angle U and angle S. You can use one letter for both of those because there's not multiple parts of either U or S. In number 2, we're trying to now find, given that we already have angle L and angle P that are congruent, angle P and angle Q, excuse me, and we're trying to figure out what we can conclude from there. The two opposite sides have to be congruent to each other because of the converse of the isosceles triangle theorem. Okay? And with the two sides that we know that are congruent are PR congruent to RQ. So yes, we're going to use these particular theorems, okay, extra information you know about isosceles, to now do this proof. So notice how there's no number that are given for the statements and the reasons. So let's first write down everything we know. We know that triangle ABC is isosceles. Okay, that's an important part. And we know that EB bisects, and in this case, angle ABC. And we all know that's because of our given. So let's look at what is already notated. Let's use the first piece of information that's given to us. We know that triangle ABC is isosceles. So we are already told in this case that we have AB and BC that are congruent to each other. We don't need to say any more about that, but what we can do is use that to help us with our next step. If you know two sides in that big outside triangle are congruent to one another, that means the angles that are directly opposite them have to be congruent to one another. So in this case, that means we have angle A congruent to our angle C. We know that is true by our isosceles triangle theorem. Because we have two sides, the opposite angles have to be the exact same. And now we're trying to use another piece of information. Again, a couple options you could do here. You could try to use the reflexive property. That would possibly be something that would work. However, it wouldn't give you a side, 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 a side, angle, side, one of the five properties we know. So what we have to use now is the second piece of information. EB bisects angle ABC. If it bisects an angle, that means your angle is split up into two. That means that in this case, we have angle ABE that is congruent to angle CBE. And we know that is true by the definition of what we know a bisector to actually be. Okay, remember, it bisected an angle, so angles have to be congruent from that. And to finish this out, okay, we have three pieces of information for both of those triangles. So we can say that the two triangles are congruent to one another, triangle ABE congruent to triangle CBE. And in this case, angle, side, angle. Now you have enough information to work on the worksheet. Please finish the worksheet, and if you get done, you can start on the review. Have a great rest of your Friday and weekend.